Hello friends, today I am going to discuss something like just we were already discussed something like a clustering method. So it's one of the famous clustering method like a K-means clusterings. So in the previous class we have discussed like a hierarchicals, cumulatives. So let's the what is the in the previous chapters we have seen the like a supervised machine learning and where the target variables or a level is known to us, and we try to predict the output based on the input features. But unsupervised learning is a different in the sense that there is the no level data and we don't try to predict any output such as a instead, we try to find interesting pattern and come up with a group within the data. So the similar value are grouped together. So when we join a new like a school and college or a college, we come across the many new faces. In everyone looks so different. So we hardly know anyone in the institute and there are no groups in place initially. Slowly and gradually, we start spending our time with the other people, and groups start with the develop, with interact with a lot of different people and figure out how similar and dissimilar they are to us. So few months down the line, and we are almost settled in our own groups or a friend. So the friends members with the group have a similar attributes, uh, linkings, test, and hence stay together. So clustering is somewhat similar to this approach is forming group based on sets of attributes. So let's start with the clusterings. So clusterings on the any sorts of a data where we want to form a groups of similar observations and use it for better decision making. So most of the time different types of the clusterings like one is the how do you get the one of the clusterings like the measure the distance using the Euclidean distance method. So suppose A and B, it's a small distance, A and B is the high similarity, and if A and B is the high distance like low similarity. So it's the Euclidean distance. Suppose A and B coordinates and A1 minus B1 whole square plus A2 minus B2 whole square, A3 minus B3 whole square, A4 minus B4 whole square is in the square roots. So we can easily get here. But so many other techniques are also calculated here. The like between the observations. So one is the Manhattan distance, Manhattan-Boyce distance, Minkowski distance, Chebyshev distance, and cosine distance, sine, cos, tan. Or we have already this means in the mathematics we have already discussed sine square and cos square. So there are some basic. So clustering is used the variety of use case these days, ranging from the customer segmentations to anomaly detection. So businesses widely use a machine learning device clusterings for profiling customers, segmentations to create a market strategy around these results. So clustering divides a lot of search engines result finding a similar object in the one clusters and dissimilar object far from each other. It recommends the nearest similar results based on the search query, and it can be done in a multiple ways based on the types of the data business requirements. So most used ones of the K-means and hierarchical clusterings. So K means it stands for the number of clusters or groups that we want to form in the given data sets. So the types of clusterings involve deciding the number of the clusters in the advance. So one is the centroid, another is the variance. So centroid refers the centered data point at the center of the clusters or groups, and so each clusters groups contains the different numbers of the data points that are the nearest to the centroid of the clusters. So the variance is the total sum of intra-clusters distance between centroid and data point within that clusters. So the variance keeps on decreasing with the increasing in the numbers of clusters. So let's today just suppose we have a data, and one is the user ID and age and weight, and we can easily plot, so we can see the all coordinates. But now today I am going to discuss the first. There are some basic steps and we try to discuss as a practical way, and then it will be better to understand how to calculate like these K-mean steps. So let's see, go on the practical. So 1 minute. One is the just we have already discussed, means hierarchical clusterings like agglomerative clusterings and divisive clusterings. So agglomerative clusterings I have all bottom up approach, and divisive clusterings like a top down approach. So the another type of the unsupervised machine learning techniques is a different from the KMeans. I have already discussed this one. And one of the just is the dendrograms is the way deciding the most optimal numbers of the clusterings, where the hierarchical clusterings can done in the multiple way also. One of the method is the nearest clusterings. So and other things, the clusterings that can be used group like a similar data points together, like a Gaussian mixed model clusterings, Fuji C-means clusterings. So first we are taking a data. Okay, let's see here. First step, just we are doing this process in the pip install PySpark, just I have already discussed, and I am running this data install, and then we will create a PySpark session. It's running, and second is the here PySpark sessions we have created, and I am also creating like this one. So there is no need, but I need to the data, so I am taking a data from the GitHub. It's good. And then we will do this one. We are selecting a data from a data. Now you can count here these data, and we want to see the how many rows. Otherwise you can also take a data from the like a SNS, and we can look here in this means df.print schema, because we are I am using a PySpark, so the all columns has been seen like a sepal underscore length, sepal underscore width, petal length, petal width, and species like a strings. So one of the here is the strings column, and I can see here later all these columns with the variables. So it's we can see here. Now I am going to the convert here the group by the species data. So I want to the analyze like the species. So all data's numerical value are similar. And now we are doing the feature engineering. So let's see the feature engineering. I have already discussed number of the projects. So the first we want to import from a PySpark.ml linear algebra, import a vectors, and from PySpark.machine learning feature, import a vector assembles. So just I have already imported, and now the df columns. So these are the columns in my data sets. So but I want to convert into the input columns as a feature way. So let's see here. So these are the input columns: sepal length, sepal width, and petal length, petal width. So just I have done here, and now I am going to the create in the assembler. So vector assemble I have already imported here. So just assemble, and it has been converted in the as a feature. So we can see our features also, but final data we will transform. This is the final data, and then I want to the convert like this. It's a this way machine learning feature standard square. So there is, let's see, it has been converted. And one of the other ways, so I am doing the, so there is no need to, you can do here, just we are getting the some error, so don't worry, don't confuse here. And now after that, I am using the KMeans clusterings method. So from PySpark.ml.clusterings import a KMeans, and another the PySpark.ml evaluations import a clusterings eigen value weighted. So then, and now we are creating the evaluators like a clusterings evaluators and predictions features columns, matrix names, and distance measures. We are using a square Euclides method. It's the right way. Yeah, it's a running. And then I am going to create like a errors as a list way, and while applying a for loop k in a range 2 to 10. K means it's a one of the variables, and models is the another variable, predictions is the transforms, and infra underscore distance evaluators dot evaluate like predictions, and error dot appends intra underscore distance and prints this one. So now we are doing the errors. Yes, yeah, it's a running. And then because I have started from the 2 to 10, so it will start from like a 2, and it's a running. Yeah, so it's a, yeah, this one, it's a 2 to 9. So the final data contains the input vectors, and that can be used to run a K-means clusterings. So we need to declare the value k in advance before using the K-means. So we have already discussed 2 to 10. So we import like a K-means from the PySpark library, we have already done, and then K-means from a PySpark library, and create the empty list would be the capture the variability like the this one, and distance measures we have applied here. So same way, just I am plotting like a k should have a minimum value of 2 to be able to build a clusters. So you can see here, we can now similarly I want to the plot, because it's a, if I am not understanding, so I can need to the plot. So go here, basic library, just import a pandas as a pd, import numpy as a np, import matplotlib dot pyplot plt, and clusters numbers range 2 to 10, x labels, y label, just I have already. So let's see here clusters. So it has been plotted, and now we can analyze how it's a working. Look here, it's a v. So this is, so here we can see like a k will equal to 3 seems to be the best number of the clusters, as we can see a sort of elbow formations between 3 and 4 values. So we build the final clusterings using k will equal to, it's a 3, k will equal to, it's a 3, and it's the k will equal to 3. So I can take a k will equal to 3. It's a, so I am going to the k means like a feature, and k means the clusterings gives the 3 different cluster based on the iris data. So we certainly are making the few of the allocations wrong, as only one category has 50 records, because all these category has been divided in the 3 equal parts. So we certainly are making a few of the allocations wrong, as only one category has 50 records in the groups, and the rest of the category are mixed up. So we can use a transform functions to assign the cluster number to the original datasets and use by groups. So let's see, here I am using first k will equal to 3. So now we can specify these data like this. Okay. Yeah, so let's see here, it's a data look like this. So we can use the transform these functions. So let's go and transform this data. Then we can see here like this. So it's a transform this data. So it can be observed the Setosa species is perfectly grouped along with the Virginica seems to fall within the 2 different groups. K means can produce a different results over time, as it chooses the starting point centroids randomly. So every time, hence the result that you might get, the k means clusterings might be totally different from these results, unless we use to see to reproduce the results, and the seed ensured a split, and the initial centroid value remains consist through the analysis. So I hope, and we can also visualize like this way. So you can use like a 2 pandas predictions. So let's see, and then we can see select. So we can see here the petal length, stiple length, petal width, and species features, and each and everything. And then we can use like a matplot and other things, and we want to the plot like a 3D. So it's a visualizations. Clusters is the final step. So we can visualize the new clusters with the help of the Python matplot library, in order to convert in the Spark data frame into the Panda data frame. So I hope it helps somebody. So thank you very much, and next time we will discuss some more.